All right, so we're ready to finish up section 5.5 on graphing sine and cosine functions. So we're left on page 8. I always have a couple pages left. We're at example 4. So we're given y equals 2 times cosine of 3x minus pi plus 3. We want to identify the amplitude, period, phase shift, vertical shift, and then be able to graph a full period. Right, so just labeling the parts, right? So A is 2. This part would be B, right? So B is 3. C is negative pi, it would just be pi. And then D is 3. Right, so what we want to do now, we can start identifying these things. So the first thing is the amplitude. So remember, the amplitude is the absolute value of the A value, which would be the absolute value of 2, which is just 2. Right, so my amplitude is 2 here. My period, remember, is equal to 2 pi divided by B, which would be 2 pi over 3. The next thing we want is the phase shift. The phase shift is equal to C divided by B. So this would be pi over 3. Right? And then other thing, we identify the vertical shift, which is just equal to D, which is 3 in this case. Right? So I'll write this in another color. But another thing that's nice to do here is let's find one full cycle. So remember, one full cycle is 0 less than or equal to bx minus c less than or equal to 2 pi, right? So this part is the bx minus c. So we would have 0 less than or equal to 3x minus pi less than or equal to 2 pi. Right, so let's solve that. So we have 0 less than or equal to 3x minus pi less than or equal to 2 pi. So we could add pi to both sides, and we get pi less than or equal to 3x less than or equal to 3 pi, and then divide by 3. So we get pi over 3 less than or equal to x less than or equal to pi. Right, so this is my interval that I want to be on. And then don't forget also what we could do is we take the period, divide by 4, and so that would be 2 pi over 3 divided by 4, which would be equal to 2 pi over 12, which is pi over 6. So this is the what I add to get the critical points. Right, so essentially we'll come over here. We have x and y equals 2 cosine of 3x minus pi plus 3. So we want to start at pi over 3 and add pi over 6 each time, right? So if you want to make this a little easier, this would be 2 pi over 6. So then we'd have 3 pi over 6, and then 4 pi over 6, and then 5 pi over 6. We want to keep going until we get to pi. So next would be 6 pi over 6, which is just pi. Right, so that's where we'd stop. So let's see, 4 pi over 6, we can reduce this down to be 2 pi over 3. And 3 pi over 6, we can reduce that down to be just pi over 2. So now if we just plug in these values, and something else that we can do, so I've been plugging them in and figuring them out by hand. Another thing we could do is come here and let's grab a table. So we need to put the function into y1. So that would be 2 cosine of 3x minus pi plus 3 is our function. Another thing, my mode should be in radians here. So then we would go to second table settings. And then we want to start the table. Let's see, we were starting at, was it pi over 3, I think? Let's check. Yeah, pi over 3. And then we're going up by pi over 6, right? So we have pi over 3 here, and then pi over 6 here. There, get a table. So then here's the table I need, right? These are the numbers to fill in. Right, so pi over 3 would be the first one. So this would be 5, 3, 1, 5, 3, 1, and then 3, 5. Right? So if you wanted to keep doing it by hand, you could, right? So you just plug in pi over 3, plug it into here. So the first one would be, let's see, 3 times pi over 3 would be pi. Pi minus pi is 0. So then cosine of 0 is 1. 2 times 1 is 2, plus 3 is 5, right? So you could, keep working it out by hand, but I won't do it this time, right? We've done it a bunch of times. So then to be able to graph this, need to plot all of our points. So we have 1, 3, 5. Right, so right down the center is going to be almost like a dashed line, right, where it cuts the graph in half. So before that was like the x-axis, right? So like if I come up here to my other graphs that we've done, notice that the part that kind of cuts the graph in half is the x-axis. Right? So like where here's one amplitude and down here's another amplitude. Right? So then plotting these points, let's see. Well, we need to label the x-axis. So we had pi over 3, pi over 2, and then 2 pi over 3, and then 5 pi over 6, and then pi, right? So pi over 3 matched up with 5, and then pi over 2 was at 3, 2 pi over 3 was at 1, just a quick note here too is I don't have a constant interval on the x or the y axis, right? So let me add in. So I need to add in here. Let this be pi over 6, and then let's just add in 2 and 4, right? There, now that's correct, right? Because before I was going 0 to 1 and then adding by 2, so I can't add 1 and then add 2, and then down here the pi over 6 thing, I was adding by pi over 6 but started at pi over 3, so I just need to fix that to make my graph better. So then 5 pi over 6 matched up with 3, and then pi matched up with 5. Right. So here's 1 period. Right, typical period. Just 1 full cycle. All right, so we have 1 more of these. So let's identify all the parts, right? So first of all, one thing you'll notice is that we wanted B to be positive, right? So this part is my B, but notice it's negative, right? So what we want to do is rework this first using odd-even functions, so that way B is positive, right? So that's an assumption that we made, so we have to fix that. So this would be equal to -2 times sine of, and I'm just going to pull out a factor of -1 inside, so that would be pi over 6 x plus pi over 2 and then plus 1. And then sine is an odd function, right? So what would happen is this -1 would make the front negative in front of the sign, but since it's already negative, you'd have a negative times a negative, so it would end up being positive, right? So we'd have 2 times the sine of pi over 6 x plus pi over 2 plus 1. Right? So then we can label my parts. So A is 2, B is pi over 6, C would be negative pi over 2, right? Because it's minus, should be minus C, and then D is 1. Right? So again, how I'm identifying the A, B, C, D, I'm just looking at the function in these forms, right? And just and then just identifying what the value is. Right. So then remember that amplitude is equal to the absolute value of A, which would be the absolute value of 2, which is just 2. So next we need to find the period. The period is equal to 2 pi over B, which in this case would be 2 pi divided by pi over 6, which would be 2 pi over 1 times 6 over pi. So the pi's end up canceling. So here we get 12, right, for the period. The phase shift, let's see, is C divided by B. So this would be negative pi over 2 divided by pi over 6, which would be equal to negative pi over 2 times 6 over pi. So the pi's cancel, so we get negative 6 over 2, which is negative 3. Let's see, so we got the amplitude, period, phase shift. Then next we want to find the vertical shift. So the vertical shift would be equal to D, which is 1. Right. So we found all of those parts. So then the next thing that I would want to do, remember, is one thing that we want is to take the period divided by 4. So the period is 12, so we have 12 divided by 4, which is 3. So this is the increase on the x-axis, right? And then typical period is going to be between 0, bx minus c, less than or equal to 2 pi. So we plug that in. So this would be the bx minus c. So we'd have 0 less than or equal to pi over 6x plus pi over 2 less than or equal to 2 pi. So I think what I'm going to do to start with is just multiply everything times 6. Make this a little simpler. So this would be 0 less than or equal to, so 6 times pi over 6 is pi, And then 6 times pi over 2 would be 3 pi. That's an x still, right? Pi x plus 3 pi less than or equal to, so 2 pi times 6 is 12 pi. So now I can subtract 3 pi from everything. So we get negative 3 pi less than or equal to pi x less than or equal to, so 12 minus 3 is 9 pi, right? And then divide everything by pi. So we would have negative 3 less than or equal to x less than or equal to 9, right? So this is what the typical period will be on. Right? So so when I make my t-chart, we want to start at negative 3, and then we were increasing by 3, and we're stopping at 9. So we'd be at 0, 3, 6, 9. Right, so same thing, it's good to practice doing it by hand, but for time's sake and just to help you get comfortable with your calculator as well, I'll just put it in here. So we have 2 sine pi over 6 x plus pi over 2 plus 1. So then my calculator is already in radians. So I'm going to go to the table set. We want to start the table at negative 3 and go up by 3 each time. So we get 1, 3, 1, negative 1, say 1, 3, 1, negative 1, 1. Right? 1, 3, yeah. So then now I just need to graph this. Right, so we got 1, 2, 3, negative 1. So at 1 is going to be that like horizontal line, right? It's like halfway in between the max and min, right? And then here on the x-axis, we need to go to, I'm just going to go by 3, so negative 3, 3, 6, 9. Right? So negative 3 matched up at 1. Negative, then we had 0. 0 matched up with 3. And then 3 matched up with 1. And then 6 was at negative 1. And 9 was at 1. Right. All right, so that finishes out that example. So then the very last thing here, just going over like an application. So let me get rid of the graphing calculator and go full screen here. So I'm just reading here. So it says when the graph of a data set is shaped like a sine or cosine graph, we say the graph is sinusoidal, right? So essentially it's just having like that wave-like shape, right? So there's a lot of things that model like that naturally. One, you can think about like temperature, right? So if we let, think of like time as the x-axis and the maybe the average high as the y-axis, that's going to keep going up and down with the seasons, right? So like summer is always going to come back and get a high. We're going to go back down to a low in the winter and so forth. So with this example, that's what we're doing. So we're looking at, we're told that the monthly high temperature for Atlantic City, New Jersey peaks at an average high of 86 degrees Fahrenheit in July and goes down to an average high of 64 degrees in January. assume that this pattern for monthly high temperature continues indefinitely and behaves like a cosine wave, right? So we have a cosine wave. So write a function of the form h of t equals a cosine bt minus c plus d to model the average high temperature. The value h of t is the average high temperature for month t with January as t equals 0. Right. So, so we need to, think through the parts that we need to figure out. So I don't know if it might be helpful, maybe kind of try to graph like at least a couple of points of what we know, or at least just list it, right? So what we know is that in July, whoops, I'm using a highlighter, can't write with that. In July, we have 86 degrees Fahrenheit, and in January, we have 64 degrees Fahrenheit, right? And then, just to write this out, let this be t and this be h of t. So the t value for July, or for January, we let be 0. So then for July, that would be 6, right? So in other words, what we have is we have t, we have h of t. Just to write this a little neater, we have the point 0, 64, and 6, 86. Right? So since this, behaves like a cosine wave, so let me maybe try to graph. Let me just graph cosine really quick, right? So if we just have, y equals cosine of x, let's just recall what that looks like. Right, and again, if you ever forget, you can just draw a circle real quick to help you, right? So remember, cosine is the x value. So at 0, the x coordinate here is 1, so we're going to be here. And then at pi over 2, we'll be at this point. The x value is 0. And then at pi will be here, the x value is -1. And then 3 pi over 2 will be here, which the x value is 0. And then back at 2 pi, the x value is 1. Right, so the cosine wave looks like this, right? So notice this is like a high value, right? A max value that's going to occur on the x-axis. So in our case, kind of just like a rough sketch of what we have is, like here is 64. I'm going to have a point here at t equals 0. So if this is my t-axis, and this is, let me actually get some more room here. So this is like my h of t axis. This is my t axis. So we have 64 and 86 mapped. And then so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right, so forth. So then at t equals 0, we're at 64. So that would be here. At t equals 6, we're at 86. So notice how it's kind of like these two things flip-flopped. This point and this point, they kind of rotated. So that would be a reflection about the x-axis. So if you remember, right, because what I'm thinking is it looks like this graph. Let's see, it would go upward at some point and like kind of max out here and so forth. It, depending on how it looks. Right. So far what that tells me is that the a value has to be negative, right? So in other words, the function we have so far is h of t equals. So we're going to have negative, and then we need to fill in this a value. So fill in a there, and then we would have times cosine of something times t, right? So we need to fill in this blank, which would be our b value, and then minus this value here, which would be c, and then plus this part would be d, right? So these are the parts that we'd fill in. So so I can tell, since we have a starting point, like a minimum point on the y-axis, that means I'm not having a shift to the left or right at all. So the part that deals with the horizontal shift is the c value. So since I don't have a shift at all, that's going to be 0, right? Another thing we need to define is the amplitude, right? So the amplitude would be half of this distance I just marked in red, right? So a is going to be equal to 86 minus 64 divided by 2, right? Half the distance from the tallest point and the smallest point. So 86 minus 64 divided by 2. So if you want, you can use your calculator really quick. So 86 minus 64 divided by 2, we get 11, right? Also, what we know is that the period is equal to 2 pi over b. So the period in this case would be 12, right? There's 12 months. So after 12 months, we just repeat the cycle, right? So the period is 12. So we can use this information to solve for b. So I can multiply, both sides by b. So we get 2 pi equals 12b. And I can divide both sides by 12. We get pi over 6 equals b. Right, so this is pi over 6. The a value of the period, the amplitude was 11, and that was c. So then the only thing else I need to fill in is d, right? So halfway in between is where this dashed line is that we just talked about is going to be, right? So if we think about it, typically cosine, like in this graph, that dashed line is the x-axis. So if I can figure out, where this line is, that'll tell me the vertical shift up, right? So in other words, what I need to do is take 64 plus the amplitude, right? So this part is going to be 64 plus a, which is 64 plus 11, which is 75, right? So this corresponds with 75. So that's going to be the horizontal shift upward, right? Because it's like you shifted the x-axis, that dashed line up, right? So then this is my function, right? We just had to figure out all the different parts. So I can clean this up a little bit. So I could make this, let me grab a different color. This would be h of t equals negative 11 cosine of pi over 6t, and then I don't have to write the minus 0, plus 75. Right? So that is the function that I'm coming up with, right, for part A. So then from part B, we're asked to graph this and graph those 2 points, or 3 points, and check the accuracy of the model, right? So I'm going to use Desmos to do this. Let me attach my keyboard back on. Right. So here I'm going to use Desmos. Right, so see with Desmos, I want to graph these points 0, 64, oops, 6, 86, and 12, 64. I'm going to mark the label. And then put our function in, h of t equals -11 cosine of pi over 6 times t plus 75. Right, so you can see here's our function, and we're checking the accuracy, but you can notice that all three of those temperature points are on our function, right? So that's a good sign, right? So this is accurate, right? And this is the right function, right? All right, so that's all I have left for today. So hopefully you feel comfortable graphing sine and cosine functions. So we're using a lot of things that we did in college algebra, right, with different transformations on parent functions and so forth. Right? All right, so if you have questions, make sure you let me know.